Look at this pond behind me. It is completely frozen over. You could practically skate on it. Every winter, lakes, ponds and puddles turn into solid ice. But right now, the ocean waters near the poles are facing the exact same freezing temperatures. Yet, the vast majority of the ocean stays liquid. How is that possible? Why does the ocean not freeze solid like our lakes do? Today, we are unlocking the incredible physics and chemistry behind the world's biggest body of water. Welcome back to Keen to Learn. To understand this mystery, we have to look at the water molecules themselves. Fresh water freezes at exactly 0 degrees Celsius or 32 degrees Fahrenheit. When fresh water cools down, the molecules slow down. They easily link up into a tight, organized, geometric grid to form ice crystals. But the ocean is packed with dissolved salts, mostly sodium and chloride. When salt dissolves in water, it splits into ions. As ocean water cools down, these salt ions act like ultimate party crashers. They physically get in the way, blocking the water molecules from binding together. You have to drop the temperature much lower to get salt water to start freezing. But lowered freezing points are only half the story. The second reason comes down to depth, density, and a giant underwater elevator. In a shallow lake, the top layer of fresh water cools down quickly and sinks. It happens fast because lakes are relatively shallow. The ocean is entirely different. It averages nearly 4,000 meters deep. When the surface water gets cold, it becomes denser and sinks. This forces warmer water from the deep ocean to rise to the top. Before the surface can freeze, the ocean tries to cool the entire water column. Because the ocean is so deep, this giant cooling process takes an immense amount of time. Finally, we have the element of constant motion. Lakes are mostly still, which makes it easy for ice crystals to anchor and grow. The ocean, however, never sleeps. It is constantly churned by powerful winds, massive crashing waves, and global ocean current. This constant agitation acts like a giant blender, breaking up any ice crystals. When you combine salt disruption, depth delays, and motion, the ocean becomes virtually unfreezable. Now, even with these natural defenses, the ocean can freeze in extreme cold. But right now, this vital ice is in serious trouble due to climate change. As global temperatures rise, huge glaciers and ice sheets melt at unprecedented rates. This dumps massive amounts of fresh water directly into the salty polar oceans. Because fresh water is less dense, it sits on top, forming a fragile layer. This disrupts the entire global ocean conveyor belt we just talked about. White ice acts like Earth's giant mirror, reflecting sunlight back into space. When it melts, the dark ocean absorbs that heat instead, creating a dangerous feedback loop. Protecting our oceans and understanding how they regulate our climate is the ultimate science lesson. Nature has a delicate balance, and it is up to us to keep learning. If this video sparked your curiosity, smash that like button. Don't forget to subscribe to Keen to Learn and hit the notification bell. Let me know in the comments below. What scientific mystery should we explore next? Until next time, keep questioning and keep learning.